Hello and welcome to your geometry recording for the week of December 5th, and we're also working in the week 16 folder. We are about 13 days out from the last day of the semester, so I like to keep that countdown going. So that everybody's aware of how much time is left, especially if you're working on getting caught up or getting your grade to a certain percentage that you want. Keep in mind that we are working in Unit 4. I'm no longer accepting redos for Unit 3 since we have moved on to Unit 4, where we're focusing on similarity. So Unit 4 is all about similarity. I am starting with a warm-up question that actually is asking you if you can prove these two triangles. So we're referring to triangle LNS and triangle KNW. Can you prove that those triangles are congruent? And we're going to review some of the postulates and theorems that we learned about and ways that we can prove that two triangles are congruent, because we're actually going to use some very similar theorems with proving that triangles are similar this week. So before we move on to proving triangles are similar and how we do that, let's remember how we prove triangles are congruent, because you're going to find that the ways to prove triangles are similar are very similar, are very, I used that word twice, are very, there's a lot of overlapping. So go ahead and click pause and look at these two triangles and decide if there's enough information to prove that those triangles are congruent. And then when you're ready to check your work with mine, go ahead and click play. All right, so I see a lot of ticks, and remember the ticks are very helpful for us. So there's two ticks on this leg and two ticks on this leg, so we know those legs are congruent. Then there are one tick on this leg and one tick on this leg, so we know those legs are congruent. And then there's an arc on an angle here. This angle and this angle we know are congruent as well. So what information are we given? So it looks like we've got a side, an angle included, and another side. So that angle is sandwiched between two sets of congruent sides. So that allows us to use the side angle side postulate. So yes, we can prove that those triangles are congruent. We can prove they're congruent by using the side angle side postulate. So remember all the different postulates we learned: angle, side, 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 angle, side, angle, side, and the hypotenuse leg. Those were all the different postulates that we used to show that two triangles are congruent. And I'm going to go ahead and move on to the next slide. Just some reminders that the last day of the semester is about 2 weeks away, 13 days to be exact, and I'm no longer accepting redos from Unit 3. So this week, as I mentioned, we're going to look at how we can prove triangles are similar. So we're not looking at congruency anymore, but similar. And remember, when two objects are similar, they will have sides that are proportional, and congruent angles. Remember, congruent symbol is this, and the similar symbol is just that. Then we're going to look at the Unit 4 quiz, and then we're going to look at applying properties of similar triangles. You're also going to do a short reflection on how you did on the Unit 3 test. So when you do the Unit 3 test reflection, you will need to make sure that you're going through and looking at how you did on the Unit 3 test. So make sure that you have submitted that so that I can grade that and you can complete the Unit 3 test reflection. So moving on, All right, so what are similar triangles? So again, we learned that any similar figure, whether it's a triangle or some type of quadrilateral or any number of sided figure, the corresponding angles are always going to be congruent and the corresponding sides are always going to be proportional. So we learned that last week. So there's only 3 ways to prove that triangles are similar. To prove triangles were congruent, we had more than 3 ways, but there's only 3 ways, and here they are. So some of them, let's start with the 2 that look familiar. Side, 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 angle, side, and then the new one is angle, angle. So they're a little bit different. We use these a little bit different. Before, when we used the side, 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 all the corresponding sides had to be congruent. That is not true when we're proving triangles are similar. The angles, the corresponding angles being congruent, that doesn't change. But the only thing that changes is when you see the side, that's going to represent proportional sides now. So corresponding sides will be proportional. So the and this is what I'm referring to here is that the corresponding sides will be proportional. So when you see the side, when you were proving triangles were congruent, that meant that you had to find sides, the corresponding sides that were congruent. Where now, when we're talking about similar, our corresponding sides will be proportional. Corresponding sides proportional. I should move that. Hold on a second. So I just switched around that order once I added corresponding there. That didn't make sense anymore. So when you see the capital S, that's going to represent corresponding sides that are proportional. So let's take a more in-depth look at the 3 ways that we can prove triangles are similar. The first one is the angle-angle similarity postulate. Just angle-angle. So what that means is if 2 angles on one triangle are congruent with 2 angles on another triangle, then the triangles are similar. So if we can prove 2 sets of corresponding angles, then we can prove that the entire 2 triangles are similar. So we only need 2 angles, that's it. And then the side angle side similarity theorem. So notice I have this little symbol right here. Remember, that's the similarity symbol, and that I had that back here too, so that we're not getting confused with the congruent postulates that we used. So here, let's take a look at this. If an angle of one triangle is congruent to an angle of a second triangle, and the sides, including, remember that means we got to have them sandwiched in there, are proportional, then the triangles are similar. So let's take a look at this in a little bit more depth and really understand what I mean about those 2 sets of proportional sides. So this side here corresponds with this side here. So it's the short leg. We've got the hypotenuse here, and the long leg here, and a short leg here. Hypotenuse here, long leg here, short leg here. So the 2 shorter legs would be the corresponding legs. And if we look at those and compare them, so it would be 2/3. If I compare AC over, DF, we get that ratio of 2/3. Now we're going to do the same thing and see if the other set of corresponding sides are proportional. So this leg here corresponds with this leg. So I'm going to write a ratio comparing side BC over side EF, and when I do that, I get 4/6, which reduces to 2/3. So our sides are proportional because they both reduce to this same ratio of 2/3. So that means the sides are proportional. Those sides are proportional. So we have 2 sets of proportional sides with a set of congruent angles sandwiched in, and using side angle side similarity theorem, we're able to prove that those 2 triangles are in fact similar. I'm going to move on to the next slide, so if you need more time here, go ahead and click pause. And then the last one is the side similarity theorem. So if we are able to prove that all three sets of corresponding sides are proportional, then the triangles are similar. So let's take a look at how that works. This side here corresponds with this side. So can set up a proportion there. So that would be 6/8. And then let's look at another set of corresponding sides. These two sides, exact same ratio, right? Another 6/8. And then one more set of corresponding sides. What color have I not used? How about red? This side here and this side here is 3/4. So are all those proportional? Well, what is this 6/8 reduced down to? I can divide out a 2 and a 4. Oops, a 2 and a 2. I'm sorry. I was getting ahead of myself. The bottom was going to become 4. So look at these two fractions. They're the same. We can reduce all of the side ratios to 3/4, which means that all those sides are proportional, which then means that these two triangles are in fact similar. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so proving triangles are similar. Let's use what we just learned to look at two triangles and determine if these triangles are similar. And if so, what theorem can we use to prove that they're similar? And there's a review of all the three postulates that we learned. Those are the only three postulates that we can use. We can't use angle, side, angle anymore. So there's only three that we can use for proving figures are similar. So let's look at what we have. I see first, the easy one to look at is that we've got a set of corresponding congruent angles. So we've got an angle. Then let's look at our sets of corresponding sides. So we've got this side here, which is corresponding to, whoops, is it corresponding? Yep, it's the bigger of the two numbers. So 5 is bigger than 4, 15 is bigger than 12. So these two sides are corresponding. What would that fraction be? And when we compare those sides, the ratio, I'm sorry, not the fraction, the ratio would be 5/15. Then we've got another set of corresponding sides, the two shorter sides. This side here corresponds with this side, so we set up another ratio comparing those sets of corresponding sides. And do these two ratios, do they reduce to the same number? So what can I reduce 5/15 to? 1/3, right? Divide a 5 out of both the numerator and the denominator to get 1/3. Can I reduce 4/12? I can. I can divide out a 4 of both my numerator and denominator here and get 1/3. So because they both reduced to the same ratio, we've got two sets of proportional sides with a sandwiched set of congruent angles. So that means we can use the side angle side theorem. And that, yes, these are similar. These are similar triangles. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so go ahead and look at this one on your own and decide if these two triangles are similar. So try this one on your own, click pause, and then when you're ready to check your work with mine, go ahead and click play. So again, very similar to the example we just did, we have a set of congruent angles, and then let's compare the corresponding sides. So 12 is smaller than 15, so that's going to link with the smaller side on this triangle, 36. Let's write that as a ratio, so 12/36. Then our other set of corresponding angle or sides is 15 and 45 over here. So let's write that as a fraction or a ratio. I should say ratio. And then let's reduce these and see if they reduce to the same ratio. So it looks like I can divide out a 6, right, from each to reduce that to 2/18. And I can reduce that even further to get 1/9. Whoops, something doesn't look right, and I see what it is. So let me go fix that. 36 divided by 6 is actually 6. And then when I reduce that, That's going to reduce to a 3 on the bottom. Got that fixed. All right, so it reduces to 1/3. Does 15 over 45, does that reduce to 1/3? So it looks like I know I can divide out of 15 out of both, and I get 1/3. So yes, these are similar, and we can use the side angle side theorem again. I'm going to move on to the next slide, so if you need more time, go ahead and click pause. Let's see here. So now we've learned a lot about similar triangles, and we're going to apply those properties in the last session that you're doing this week. So this is the type of problem you'll see in that last session this week. So what we're going to do is use what we know about similar triangles to solve for some unknowns. So let's see what we're given here. So we're given that AB, this side here, is parallel to this side. And we are given that AB is 4 and that CD is 8. And we're given AE is 3x plus 4, and the length of ED is x plus 12. And we want to find the lengths of AE and DE. So we want to find the lengths of these two sides right here. But in order to do that, we need to solve for the x's, right? We need to solve for the x's. So the first thing that we need to do and able to solve for x is we need to prove that these two triangles are congruent. So we need to prove that triangle ABE is congruent to triangle CED. So to do that, we're going to use the information given that these two sides are parallel. And then remember what we learned about transversals and parallel sides. By using the alternate interior angles theorem, we know that angle A is congruent to angle D because they're on alternating sides of this transversal. So remember, we've got these two sides that are parallel, and then we've got a transversal that comes in. So these two angles, because of the alternating interior angles theorem, we know that these two angles are congruent. We also know that these two angles are congruent because of the alternating interior angles theorem. So now, and then these two sides, now that we have two angles, remember we can use the angle-angle similarity theorem to prove that the triangles are congruent. So that triangle AEB is congruent to triangle CED. So now that we've proved these two triangles are congruent using the angle-angle similarity postulate, now we can set up some proportions, right? We can set up some proportions now. So when we set up the proportion, we're just going to set up two ratios comparing our corresponding sides. We're going to set up two ratios comparing our corresponding sides. So I'm going to color code these. Go back to the purple because these two sides are corresponding. So let's set up a ratio. So we would have 3x plus 4 over the corresponding side on the other triangle. And then set that equal to another set of corresponding sides. And we know that this side here corresponds with this side. So I'm going to set that equal to 4 over 8. Remember, whatever side you start with, like notice that the numerator has all the information from this triangle. So both numerators have the information from this triangle, and the denominator has information from our second triangle. And now to solve, we're just going to cross multiply. We're just going to cross multiply to solve. So we're going to have 4 times x plus 12 equal to 8 times 3x plus 4. Now we just have a nice algebraic equation. We need to start by distributing, so 4x times 4 times 12 is 48. Set that equal to, we're going to distribute on this side. Whoops, that's 24x plus 32. Solve for x. I'm going to get all my x's on one side of the equation and all my constant terms on the other side. So I'm left with 48 on my left side of the equation, 20x plus 32. I'm going to subtract 32 from both sides. I'm running out of space over here. I'm going to continue up right here. So 48 minus 32 is what? 16? Set that equal to, so it came up over here. 16 equals 20x divided side by 20. So we've got a fraction. So we get 16 20ths, which reduces, right? That reduces. Let's go ahead and reduce that fraction. I think I can divide out, what, 4 out of each, our numerator and our denominator. So we get 4/5 equals x. And then we would need to go ahead and, you know, in this case, let's just solve for x because we're running out of time. If we needed to, let's change the directions. That's sneaky, right? If we needed to find the lengths, we could plug those in, but I don't want this recording to get too long, so I want to stop there. So we solve for x. And if we needed to, we could plug that in and find the length of each of our sides, but we're going to stop there. All right, so let me put up our key phrase assignment. So I have 2 triangles here below, and I've got their angles labeled, and some of them labeled. I want you to tell me if you have enough information to prove that the triangles are similar, and if so, how. So you learned how this week. You can solve or show triangles are similar. This angle right here is 60. It's hard to see, but it is 60. That angle is 60 degrees. So that's your question. So this is the end of the recording. Make sure you complete the key phrase assignment, and if you need any help with this week's work, let me know. Have a great rest of your week.